thermochemical equations are given below. C graphite plus O2 giving CO2, enthalpy is X kilojoules per mole. C graphite plus half O2 giving CO, delta H is Y kilojoules per mole. CO plus half O2 giving CO2, delta H is AZ kilojoules per mole. Based on the above equation, find out which of the relationship given below is correct. So based on the above details, we have to find a relationship. Options are given. Okay. So from these three equations, or by using two equations, try to find the third equation. They have given three equations. So taking any two equations, try to find the third equation. So here C graphite. Okay. Now third equation, if you consider third equation, you cannot find any C graphite. C graphite is not present in third equation, right? So I am subtracting first equation and I am subtracting second equation from first equation. Subtracting means, so it will become minus C graphite minus O2 minus CO. This will become minus Y, right? So this minus C graphite and C graphite will cancel each other. O2 minus O2 remaining, you will get, please neglect this equation. Okay, we are considering only first and second equation. First minus second, C graphite will cancel each other. O2 minus half O2, you will get half O2, right? O2, 1 O2 minus half O2, you will get half O2, giving CO2 minus CO. Now I am taking this CO to this side, minus CO, I am taking this minus CO to this side. So you will get CO plus half O2 giving CO2. If you refer the third equation, you can see this is the third equation, CO plus half O2 giving CO2, right? So by using these two equations, we made third equation. By using these two equations, we made third equation, right? Okay, so first equation minus third equation. What is the enthalpy value of first equation? X. What is the enthalpy value of the second equation? Y. So first equation minus second equation, that is X minus Y. So it will become delta H is equal to X minus Y. Now this is the third equation. What is the enthalpy value of third equation? Is Z. So X minus Y is actually Z. Okay, so relation is X minus Y is equal to Z. First X minus Y is equal to Z. It is not given in the options, so I am taking X minus Y is Z. It is not given there, so I am taking Y to this side. X is equal to Y plus Z. X is equal to Y plus Z. Answer option 3. Answer option 3. I think it's clear. I'll explain once more. Here three equations are given. So by using two equations, by using any two equations, you can, if you can make the third equation, then you will get a relationship. They are given three equations. By using any two equations, you can use any two equations, and by using those two equations, if you can make the third equation, then you can find the relationship. Okay, so here in first equation C graphite is there, second equation C graphite is there, third equation there are no C graphite. So try to cancel these two. So first equation minus second equation. So minus, 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 this will become minus. These two will cancel each other. O2 minus half O2 will remaining, simply O2, half O2. CO2 minus CO. I am taking this minus CO to this side. CO plus half O2 giving CO2. Third equation. We got third equation, right? Now CO plus half O2 giving CO2. Now this is formed by subtracting first minus third. So you will get X minus Y. Now this is actually third equation. So X minus Y gives third equation. Enthalpy is Z. X minus Y is equal to Z. So X is equal to Y plus Z. Answer option 3. To question number 36. Following reactions occurs in automobile. 2C8H10 plus 25O2 giving 16 CO2 plus 18 H2O. The sign of delta H, delta S and delta G would be. So you have to find the sign of delta H, delta S and delta G. Now, what type of reaction is this? This is combustion reaction. We are burning C8H18. We are burning CH8H18. That is, we are burning C8H18. So this is a combustion reaction. For combustion reaction, delta H is always negative, because if you burn something, energy will be released. For example, if you are burning this paper, if you are burning this book, enthalpy will be released, right? If you are burning this pen, energy will be released. So for all combustion reaction, energy will be released. So delta H value will be negative. So delta H, we got the value of delta H, it is negative. Right. Now, what is delta S? For calculating delta S, try to find the number of moles in reactant and product side. In reactant side, 25 plus 2, 27 gaseous molecules are there. The product side, 18 plus 10, 28 plus 6, 34 gaseous products are there. 28 plus 10, 28 plus 6, you will get 34. 34 gaseous products are there. So number of moles of products, gaseous product is greater than number of moles of gaseous reactant. So number of moles of gaseous products is greater than number of moles of gaseous reactant. So entropy increases. If number of gas molecule increases, then entropy will always increases. So delta S value is positive. Delta S negative, delta S positive. Now, what about delta G? Is this a spontaneous reaction or a non-spontaneous reaction? This is a spontaneous reaction. I think you remember, when we burn a paper, this burning means it is an initiation. After initiation, the paper will burn without any external, without any help from external forces. Burning of a paper is an example for spontaneous process, because first we initiate by lighting the paper. When we heat the paper, okay, that is the initiation energy. By using initiation energy, the paper will burn. Okay, so burning of paper is an example for spontaneous process. Likewise, burning of paper, here we are burning, we are combusting this organic compound. So oxygen, here we are combusting. Oxygen means burning. Oxygen, if the presence of oxygen indicates burning, we are burning this compound. Always combustion reactions are spontaneous process, because for combustion reaction we need to supply only initiation energy. First we have to supply the energy, that is for initiation. After supplying initiation energy, they will burn without the help of any external force. So here delta G value is negative. I think these two, delta H and delta S are clear. And last one is delta G. Combustion reaction. For combustion reaction, first we have to give an initiation energy. Initiation energy is required. But after giving initiation energy, they will burn spontaneously. Okay, so what is spontaneous process? Process which take place by itself or by an initiation. So we are supplying heat energy to initiate the reaction. After supplying heat energy, it will burn continuously, spontaneously. So delta G value is negative. So answer is delta H negative, delta S negative, and delta G value negative. Answer option 4. Delta H negative, delta S positive, delta G negative. Answer option 4. Option 4 is the right answer. So question number 37. When 5 liters of gas mixture of methane and propane is perfectly combusted at 0 degrees Celsius and 1 atmosphere, okay, 16 liters of oxygen at same temperature and pressure is consumed. The total, the amount of heat released from this combustion is, okay. So here we are taking 5 liters of mixture of methane and propane. 5 liters of gaseous mixture methane and propane. So I am taking 5 liters of mixtures of methane and propane. Okay. Okay. Now it is perfectly combusted. This is heated, burned in the presence of oxygen at temperature 0 degrees Celsius. At temperature 0 degrees Celsius, 0 degrees Celsius temperature, it is given there. Temperature is 0 degrees Celsius, which is equal to 273 Kelvin, and pressure 1 atmosphere. And you know this condition is known as STP. So under STP condition, standard temperature pressure. Temperature 273 Kelvin, pressure 1 atmosphere, that is standard condition. So 5 liters of mixture of methane and propane are burned or combusted under 0 degrees Celsius, that is 273 Kelvin temperature and 1 atmosphere pressure. Okay, this condition is known as STP condition. Okay, Okay, now 16 liters of oxygen at same temperature and pressure is consumed. So during that reaction, 16 ml of oxygen is 16 liters of oxygen. 16 liters of oxygen is consumed. Okay, the amount of heat released from this combustion. Here, enthalpy of combustion of methane is given. Enthalpy of combustion of methane is given. It is 890 kilojoules per mole, and enthalpy of combustion of propane is given 2220 kilojoules per mole. So enthalpy of combustion of methane and enthalpy of combustion of propane are given. So I think it's clear. Question is clear. Here we are taking mixture of methane and propane, and their total volume is 5 liter, and it is combusted, it is burned in the presence of oxygen under 273 Kelvin temperature and 1 atmosphere pressure. This condition is known as STP condition, standard temperature pressure condition. Now during combustion, 16 liters of oxygen is consumed, and the enthalpy of combustion of methane is 690 Kelvin. Enthalpy of combustion of propane, it is given as 2220 kilojoules per moles. Okay, so I'm going to start to write the answer. Let volume of methane be x liter. In the mixture, let the volume of methane be x liter. Then the volume of propane will be equal to 5 minus x, because volume of methane plus propane is 5 liter. Okay, here total volume of methane and propane is 5 liter. Let the volume of methane be x liter. So volume of propane will be 5 minus x liter. Now here we are combusting, we are burning. So during combustion, methane plus O2 giving carbon dioxide and water, we have to balance the equation. Methane plus CO2 giving carbon dioxide and water, we have to balance this equation. So methane, okay, 2H2O, right? So 2CO. So methane plus 2CO2, 2O2 giving CO2 plus 2H2O. Okay, now here let the volume of methane be x liter, then volume of oxygen will be 2x liter, because here ratio is 1:2. If volume of methane is x liter, then volume of oxygen will be 2x liter. I think it's clear. Now consider this reaction. Propane, here along with methane, propane is also getting burned. So propane react with oxygen giving carbon dioxide and water. Carbon react with oxygen giving carbon dioxide, and hydrogen react with oxygen giving water. Now we have to balance the equation. So 3 carbon, let it be 3 carbon, right? 3 carbon. Now 8 hydrogen, so it is 4 hydrogen, 4 2s are 8, 3. Now we have to balance oxygen, 3 into 2, 6, plus 4, 10. So it's 5 O2, right? Now what is the volume of propane? Propane is 5 minus x. 5 minus x liters. So 1 propane is 5 minus x. So what is the volume of 5O2? 5 into 5 minus x, because here the ratio is 1:5. So volume of 1 propane is 5 minus x, means oxygen is 5 into 5 minus x. Here it is 1:2. So if volume of methane is x, then volume of oxygen is 2x. Okay, similarly, if volume of 1 propane is 5 minus x, then volume of 5 oxygen is, their ratio is 1:5, so 5 into 5 minus x. Okay. Now, total volume of oxygen. So during combustion, total volume of oxygen consumed is 16 liters of oxygen. During combustion, total volume of oxygen consumed is 16 liter. So total volume of oxygen consumed 16 liter, which is equal to 2x plus 5 into 5 minus x, because this is the oxygen consumed for methane and this is the oxygen consumed for propane. So 16 liter is equal to 2x plus 5 into 5 minus x. Okay, I think it's clear. So 16 is equal to 2x plus 25 minus 5x, right? That is, I'm writing here, 16 is equal to minus 3x. 2x minus 5x, you will get minus 3x plus 25. I'm taking minus 3x to the side. 3x is equal to 25 taking 16 this side, minus 16, so 3x is equal to, we'll get 9 and x is equal to 3. So volume of methane is x, so x is 3. So volume of methane, we got the volume of methane. So volume of methane, 3 liters. Now what is the volume of propane? Volume of propane, 5 minus x, that is 5 minus 3, 2 liters. So we got the volume of methane and propane. I think it's clear till here. Now I have to rub this side. Okay, so we got the volume of methane as 3 liter, volume of propane as 2 liter. Okay, now I'm rubbing this side. Okay, now volume of methane, we got volume of methane. Methane is 3 liters. So number of moles of methane in 3 liters. So we have to find number of moles of methane in 3 liters. So I don't know whether you remember this formula. To calculate number of gas, okay, at STP there is an equation. To calculate number of gaseous molecule, methane exists in gaseous state, there is a formula at STP. Volume of gas at STP divided by 22.4. This is the equation to calculate number of moles of gaseous molecule at STP. Here our condition is at STP, standard temperature pressure. At STP condition, number of moles of gaseous substance is calculated using this equation, volume of gas at STP divided by 22.4. Here volume of methane is 3 liter divided by 22.4. So this is the number of moles of methane. Okay, now what is enthalpy of combustion of methane? What is enthalpy of combustion? It is the enthalpy change occurring when 1 mole of a compound is burned. 1 mole compound is burned. That is enthalpy of combustion. So when 1 mole of methane is burned, energy released is 890 kilojoules. Here we have 3 by 22.4. So energy released for 1 mole, that is enthalpy of combustion. What is enthalpy of combustion? It is the enthalpy change when 1 mole of a substance is burned. Right, 1 mole. That is this much. So and the energy released for 1 mole is 890 kilojoules. So energy released for 3 by 22.4 mole of methane will be equal to, for 1 mole it is 890. For 3 by 22.4 mole is 890 by 22.4. This is the amount of energy released for methane. Same way, volume of propane. What is the volume of propane? Volume of propane, 2 liters. Volume of propane, 2 liters, right? Volume of propane, 2 liters. Now we have to calculate number of moles of propane. So number of moles of propane. Now propane is a gas at STP. Same equation, volume of gas at STP divided by 22 point. Volume of propane 2 by 22.4. Right? Now, enthalpy of combustion of propane. What is combustion means? It is the enthalpy change occurring when 1 mole is burnt. So enthalpy of propane, enthalpy of combustion of propane. Enthalpy of combustion of propane is 2220. So to burn 1 mole of propane, energy released to burn 1 mole propane is 2220. That is enthalpy of combustion of propane. Now here we have how much mole? 2 by 22.4. So energy released to burn 2 by 22.4 mole is equal to 2 by 22.4 into 2220. Energy required to burn 1 mole, that is enthalpy of combustion of propane, that is 2220. So energy released when 2 by 22.4 moles, moles of propane burned. That is 2 by 22.4 into 2220. So total energy means energy of methane plus energy of propane. That is 890 into 3 by 22.4 plus 2 by 22.4 into 2220. Add these values, that is 890, I am taking 1 by 22.4 outside from these two, remaining 890 into 3 plus 2 into 2220. After doing this, you will get the right answer. I will tell you the answer. After doing this, you will get the right answer. You will get 317.4. You will get 317.4. 317.4 joules. Okay. Answer option 3. Answer option 3. I think it's clear. Question is, we are burning methane and propane and their total volume is 5 liter. During that combustion, 16 liters of oxygen is consumed. Okay, temperature, pressure is given, that is under standard temperature, standard condition. So we have to calculate total energy released during this reaction. We have to calculate total energy, the amount of heat energy released from this combustion. So we have to calculate total amount of energy released during this combustion. For this, first we have to calculate volume of propane and methane. We got 3 ml propane, 2 ml methane. From that we calculated number of moles. Number of moles in 3 liter, 3 by 22.4. Number of moles in 2 liter, 2 by 22.4. We got number of moles. Now, energy released when 1 mole of substance is burned, that is enthalpy of combustion. Enthalpy of combustion of methane is 890, 1 mole burned. So energy released when 3 by 22.4 mole burned, you will get 890 into 3 by 22.4. Same way, enthalpy or energy released when 1 mole of propane is burned is 2220, enthalpy of combustion. So energy released when 2 by 22.4 moles burned, that is 2 by 22 into 2220. Adding those two energy values, you will get 317.4. I think it's clear. Answer option 3. Question number 38. If enthalpy of formation of 4 C2H4, CO2 and H2O at 25 degrees Celsius and 1 atmosphere pressure are 52, minus 394 and minus 286 kilojoules per mole respectively, then the enthalpy of combustion of C2H4 will be. So we have to write the enthalpy of combustion equation for C2H4. What is enthalpy of combustion? It is the enthalpy change when 1 mole of a compound is burned in excess of air or oxygen. So 1 mole of methane burned in oxygen to produce carbon dioxide. Carbon reacts with oxygen to form carbon dioxide and water. Right. So we have to balance this equation. Enthalpy of combustion. So we have to calculate enthalpy of combustion of ethane. So ethene, not ethene, it's ethene. So ethene reacts with oxygen to form carbon dioxide and water, 1 mole. So you will get 2 carbon dioxide, right? 2 carbon dioxide, 2 water, right? 2 into 2, 4 hydrogen and 2C, now remaining oxygen, 2 into 2, 4 plus 2, 6, so 3 O2. So C2H4 plus 3 O2 giving 2 CO2 plus 2 H2O. Now we have to find the enthalpy of combustion of this reaction. Now here, enthalpy of formation of substance are given. Enthalpy of formation. Enthalpy of formation of C2H4 is, okay, 1 atmosphere, this is 52, right? Enthalpy of formation of C2H4. C2H4 is 52 and enthalpy of oxygen 0, because what is enthalpy of formation? It is an enthalpy change occurring when 1 mole of a compound. C2H4 is a compound. CO2 is a compound. Water is a compound, but this is an element. Here oxygen is the only atom present. But here carbon and oxygen. So these are compounds. Formation enthalpy. Enthalpy of formation is only for compounds, not for elements. So for oxygen, enthalpy of formation 0. Now for carbon dioxide enthalpy of formation is minus 394, and for water enthalpy of formation is 286 kilojoules per mole, right? Now how many carbon dioxide are there? 2. So we have to multiply 2 with this. Here enthalpy of formation. Formation means 1 mole. Enthalpy of formation means it is the enthalpy change when 1 mole of a compound. So 1 mole of carbon dioxide is formed. At that time that enthalpy is known as enthalpy of formation, which is equal to minus 294. Here we are taking 2 moles of carbon dioxide, 2 into 394. Same way, enthalpy of formation of water, that is 1 mole, energy change when 1 water molecule is formed. That is enthalpy of formation. It is the enthalpy change accompanying when 1 mole of a compound is formed. Here there are 2 moles. So you have to multiply with the 2. Now, we have to calculate enthalpy of combustion. So enthalpy of combustion is equal to enthalpy of products minus enthalpy of reactant. This is the equation to calculate enthalpy change. We know the equation. Enthalpy change is always calculated by enthalpy of product minus enthalpy of reactant. And there is one exceptional, and it is used if enthalpy of combustion values are given. If enthalpy of combustion values are given, okay, I think you remember that question. If enthalpy of combustion values are given, we will take the enthalpy of combustion of product to reactant side. And that is used if enthalpy of combustion is given. Here, enthalpy of formation is given. For all other enthalpies, we use this formula. Enthalpy of enthalpy is equal to enthalpy of product minus enthalpy of reactant. Now, instead of any other enthalpy, if enthalpy of combustion values are given, we will take the enthalpy of combustion of product to this side. That is the way we are doing that question. But here, enthalpy formation is given, and we have to calculate enthalpy of combustion. To calculate any enthalpies, you can use this formula. Enthalpy is equal to enthalpy of product minus enthalpy of reactant. Okay, so enthalpy of product, it is 2 into minus 394 plus 2 into minus 286 minus enthalpy of reactant 52. Now, add, first multiply, then add, you will get nearly minus 1412 kilojoules per mole. This is the equation. This is the answer. Answer, I think its answer is option 4. Answer is option 4, minus 1412 kilojoules per mole. I think it's clear. I will explain once more. Please listen carefully. If enthalpies except combustion, if any other enthalpies are given, then enthalpy of the reaction is calculated by enthalpy of product minus enthalpy of reactant. Now, instead of any other enthalpy, if enthalpy of combustion is given, if it is enthalpy of combustion, no need to use this equation. Take the enthalpy of combustion of product to this side. That's enough. So, if it is negative, when you take enthalpy of combustion of product to this side, it will become positive. Okay. It is used only if enthalpy of combustion values are given. Instead of enthalpy of combustion, if any other values, any other enthalpies, formation, atomization, if any other enthalpies are given, you have to use this equation. Okay. Combustion value. Here they have given formation value. Okay. Formation value is given, enthalpy of products minus reactant. If atomization value is given, enthalpy of product minus enthalpy of reactant. But if combustion value is given, no need to use this equation. Just take the enthalpy of combustion of product to reactant side. So their sign will change. Okay. I think it's clear. So you will get the answer minus 1412 kilojoules per mole. Answer is option 4. Next question, question number 39. For a reaction to occur spontaneously, okay, first one, delta H must be negative, delta S must be negative, delta H minus T delta S must be negative, and delta H plus T delta S must be negative. Now, according to Gibbs equation, delta G is equal to delta H minus T delta S. Now, for spontaneous process, delta G value should be negative. Delta G value should be negative. So, delta G value should be negative. That means, delta H minus T delta S should be negative for spontaneous process. For spontaneous process, delta G value is negative. So, delta G value will be negative if we subtract T delta S from delta H. Delta H minus T delta S should be negative. Then the reaction will be spontaneous. So, answer is, directly we can find the answer. Answer is option 3. Delta H minus T delta S must be negative. If delta H minus T delta S become negative, delta H minus T delta S become negative, that means delta G will be, if this value is negative, that means delta G is negative, right? So reaction is spontaneous. So answer is option 2. To question number 40. Given that C plus O2 giving CO2 delta H value is minus x kilojoules. Second, 2CO plus O2 giving 2CO2 delta H value is minus y. What is the heat of formation of CO? What is heat of formation? Enthalpy of formation. So we have to calculate enthalpy of formation. Enthalpy of formation of CO. Now what is enthalpy of formation? It is the enthalpy change accompanying when 1 mole of a compound is formed from its constituent element. So their constant element of CO are C and O2. Half O2. So C plus half O2 giving CO. Okay. So we have to calculate enthalpy of formation of this equation. They have given two equations. That means we can calculate this, or we can calculate enthalpy of formation of this equation from these two equations, right? We can calculate enthalpy of formation of this equation from these two equations. I think it's clear. I think it's clear. Okay. Now, here we don't want CO2, right? We don't want CO2. And we want C. C is there. We want oxygen. Oxygen is there. We want CO. CO is there. But the problem is, here there is only one CO. Here there are two CO. So, let this equation be 1 and this equation be 2. So, I am subdividing equation 2 by 2. Because we need, in this equation, we need only one CO. Here there are two CO. So, first divide this equation by 2. So it will become, this equation will become CO plus half O2 giving CO2. CO plus half O2 giving CO2. Delta H value will be minus Y by 2 kilojoules. Right? I think it's clear. We have to make this equation, or we can make this equation from these two equations. So here there is carbon, here also carbon, oxygen, oxygen. One carbon dioxide, but here there are two carbon dioxide. So first we divide the second equation by 2. So you will get CO plus half O2 giving CO2, delta H will be minus Y by 2. I think it's clear. Okay, so I am dividing this equation, so it will become CO plus half O2 giving CO2 plus minus Y by 2. Okay, now this is equation 2. Now I am subtracting 1 minus 2. So it will become minus, it will become plus. So you will get minus CO2, cancel each other. 1 O2 minus half O2. You will get half O2. So you will get C minus CO. C minus CO. 1 O2 minus half O2 will get half O2 giving 0. Delta H is equal to minus x plus y by 2, right? Minus x plus y by 2. I am taking the CO to this side, so you will get C plus half O2 giving CO. Delta H is equal to minus x plus y by 2. Minus x plus y by 2. C plus half O2 giving CO. So we got the equation. C plus half O2 giving CO. And delta H value is minus x plus y by 2. Now, in options, you cannot find a value like x minus x plus y by 2. So I am cross multiplying this one. Minus x plus y by 2. It can be written as minus 2x plus y by 2 or y minus 2x by 2. So delta H value is y minus x plus y by 2, minus x plus y by 2 multiplying with 2, that is minus 2x plus y by 2 or y minus 2x by 2. Y minus 2x by 2. Y minus 2x by 2. Answer is option 1. I think we got the answer. Y minus 2x by 2. Y minus 2x by 2. I think it's clear. Question number 41. Identify the correct statement regarding entropy. At absolute zero of temperature, the entropy of all crystalline substance is taken to be 0. Option 2. At absolute zero of temperature, the entropy of a perfect crystalline substance is taken as positive. Option 3. At absolute zero of temperature, entropy of perfectly crystalline substance is taken to be 0. Option 4. At 0 degrees Celsius, the entropy of perfect crystalline substance is taken to be 0. Now we know that according to third law of thermodynamics, at 0 Kelvin is also known as absolute zero. ABSOLUT, absolute zero. At 0 Kelvin, entropy of all perfect crystalline substance becomes zero. This is third law of thermodynamics. At 0 Kelvin, entropy of all perfect crystalline substance. For all perfect crystalline substance, entropy will be equal to zero. This is third law of thermodynamics. So here, the right answer is option 3. At absolute zero. 0 Kelvin is known as absolute zero. Temperature, entropy of all perfectly crystalline substance becomes zero. Is taken as zero. I think it's clear. So answer is option 3. It is based on a third law of thermodynamics. Question number 42. 1 mole of ideal gas at 300 Kelvin is expanded isothermally from an initial volume of 1 liter to 10 liter. The delta E for the process is. So 1 liter of ideal gas at 300 Kelvin is expanded isothermally from an initial volume of 1 liter to 10 liter. The delta E means delta U, internal energy change for the reaction is. Delta E or delta U is equal to 0. Why it is 0? For isothermal process, delta T and delta U will be equal to 0. For isothermal process, delta T and delta U will be equal to 0. I think we have already discussed these. So here they have given the condition for isothermal. 1 mole of ideal gas at 300 Kelvin is expanded isothermally. For isothermal process, delta U will be equal to 0. They have asked to calculate delta U, so delta U will be equal to 0. Answer option 2. I think it's clear. On to question number 43. In a reaction, S plus 3 by 2 O2 giving SO3. In a reaction, S plus 3 by 2 O2 giving SO3 and plus 2x kilocalories, and SO2 plus half O2 giving SO3 plus y kilocalories. The heat of formation of SO2 is, we have to calculate enthalpy of heat of formation means enthalpy of formation. We have to calculate enthalpy of formation of SO2. Now enthalpy of formation of SO2. What is enthalpy of formation? It is the enthalpy change occurring when 1 mole of SO2 is formed from its constituent element, sulfur and oxygen, right? S plus O2 giving SO2. So it is the enthalpy change occurring when 1 mole of a compound is formed from its constituent element. So we have to calculate enthalpy of formation of this equation, and they have given 2 equations so that we can make the third equation, that is we can make this equation from these 2 equations. Now before starting to do this question, usually we write reactant giving product and enthalpy is expressed. Enthalpy is given separately like this: R giving product and delta S is equal to x kilojoules or minus x kilojoules, etc. Usually enthalpies are represented separately by putting delta H is equal to this much kilojoules. But here, instead of putting delta H is equal to this much, they have added the value of delta H with this equation. S plus 3 by 2 O2 giving SO3 plus 2x kilocalories. So this is the delta H value. SO2 plus half O2 giving SO3 plus y kilocalories. Right? So we have to make this equation in this form. Reactant giving product and delta H is equal to this one. We have to make this equation in this form. Now, R giving product, and if enthalpy is added with this equation, then you can make this equation in this form like this. R is giving P, delta H is equal to minus x kilojoules. If x value is added with the product, then if you take delta H, then the value of x will be minus x. If you represent this equation like this, then if x is added with the product, if energy is added with the product, then delta H value will be minus of that energy. If it is R giving P minus x, if it is subtracted, then R giving P, delta H will be equal to x kilojoules. Okay, so if it is added with the product, then when we write this equation in this format, R giving product, delta H is equal to If it is added, then the value will be minus of plus x into minus x. Now if it is subtracted, then R giving product delta H is equal to x. So here this is the equation 1 and this one is equation 2. Okay, this one is equation 1 and this one is equation 2. So I'm going to write in this format. Here 2x is added with this equation, so delta H value will be minus 2x kilocalories. Here y is added with this equation, so delta H is equal to minus y kilocalories. I think it's clear. It's minus x and this one is minus y. Minus x minus y kilocalories. Okay, minus x kilocalories and minus y kilocalories. Now let this be equation 1 and equation 2. I'm subtracting equation 2 from equation 1. I'm subtracting equation 2 from equation 1 because here SO3 is not needed. In this equation there are no SO3 terms, but here there are two SO3 terms. So we are going to cancel out SO3 terms. So equation 1 minus 2. So this will become minus, this will become plus. Minus SO3, they will cancel each other. Remaining 3 by 2 O2 minus 1 by 2. 3 by 2 O2 minus 1 by 2 is 2 by 2, which is equal to 1. So yes, minus SO2, 3 by 2 minus 1 by 2, O2 giving 0, delta H is equal to minus 2x plus y. Right? Minus 2x plus y. Minus 2x plus y. Minus 2x plus y. Now I'm rearranging this equation. S plus O2, I'm taking this SO2 to this side. SO2 is equal to delta H is equal to 2x minus 2x plus y, or you can write it as y minus 2x. Y minus 2x. Now we got this equation from these two equations, S plus O2 giving SO2. So delta H value is minus 2, y minus 2x. Y minus 2x. So answer is option 4, y minus 2x. I think it's clear. Question number 44. At 27 degrees Celsius, latent heat of fusion of a compound is 2930 joules per mole. Entropy changes. So at 27, temperature 27 degrees Celsius, which is equal to 273 Kelvin, a solid is converted to liquid. Okay, this reaction is known as fusion reaction. And enthalpy change during fusion reaction is known as enthalpy of fusion. It is also known as enthalpy, E-N-T-H-A-L-P-Y. Enthalpy of fusion. It is also known as latent heat of fusion. So at 27 degrees Celsius, that is 273 Kelvin, a solid, 1 mole of solid is converted to liquid. That process is known as fusion reaction. And enthalpy change during fusion reaction. Enthalpy change when a solid is converted to liquid. That is enthalpy of fusion. Enthalpy of fusion, delta H fusion, it is given as 2930 joules per mole. Now, this enthalpy of fusion is also known as latent heat of fusion. Okay. Now, we have to calculate entropy change. What is entropy change? Q reversible by T. Now, during this conversion, heat is absorbed by the solid. All the process in the universe take place at constant pressure. So here heat is absorbed at constant pressure, Qp. Right? All the process in the universe occurs at constant pressure. So here heat absorbed at constant pressure. So Q will become Qp. So delta S is equal to Qp by T. Now we know that what is Qp? Qp is delta H. We know that Qp is delta H. So instead of Qp we can substitute delta H fusion by delta T. Delta H fusion is also known as enthalpy of fusion or latent heat of fusion. In question, and instead of enthalpy of fusion they have given that latent heat of fusion. So delta H fused by T. That is, enthalpy of fusion is given as 2930 divided by change in temperature is 273 Kelvin. Then okay, 27 degrees, sorry, 273 plus 27, which is equal to 300 Kelvin. Sorry. This 300 Kelvin. Sorry, really sorry. 227 degrees Celsius means 273 plus 27, which is equal to 300 Kelvin. So divide by 300. These two will cancel each other. Now dividing 293 by 30, you will get nearly 9.77 joules. 9.77 joules. So this is the entropy, joules per Kelvin inverse mole inverse. Joules per Kelvin inverse mole inverse. Unit of entropy is, already we have discussed this, unit of entropy is joules Kelvin inverse mole inverse. So unit is joules Kelvin inverse mole inverse. 9.77 joules Kelvin inverse mole inverse. Unit of entropy is joules Kelvin inverse mole inverse. So answer is option 1, 9.77 joules per mole Kelvin. I think it's clear. Joules Kelvin inverse mole. This is the unit of entropy. So answer is option 1. I think it's clear. Question number 45. For the reaction C2H5OH liquid plus 3O2 gas giving 2CO2 gas plus 3H2O liquid, which one is true? Delta H is equal to, so relation between delta H and delta U. What is delta U? Delta E means it's delta E or delta U. Both are internal energy. Internal energy can be represented by U or E. Okay. Now according to this equation, that is delta H is equal to delta U plus delta NGRT. Okay. There are two relations connecting delta H and delta U. That is, they are delta H is equal to delta U plus delta NGRT. Second one is delta H is equal to delta U plus P delta V. But here we don't know the value of pressure, volume change, etc. So we can take this equation, delta H is equal to delta U plus delta NGRT. So what is delta NG? Number of moles of products in gaseous state minus number of moles of reactants in gaseous state. Here, this one is gas, product, these two are product, and among product, this is gas. So number of moles of product in gaseous state, 2, minus number of moles of reactants in gas, this is liquid, this is gas, 3. 2 minus 3 minus 1. So we got delta Ng is equal to minus 1. So delta H is equal to delta U minus RT. Delta U minus RT. U and E are both are same. Okay. So answer is option delta H is equal to delta U minus RT or delta E minus RT. Delta E. U and E are same, or you can write delta H is equal to delta E minus RT. So answer option, I think it's option 1. Answer option 1. Question number 46. The change in the enthalpy for a reaction 2H2O2 liquid giving 2H2O liquid plus O2 gas, the heat of formation of H2O2, we have to calculate enthalpy of, okay, the enthalpy of formation of H2O2 is given. The enthalpy of formation of H2O2 and H2O are minus 188 and minus 286 kilojoules per respectively. We have to calculate enthalpy of this reaction. So one reaction is given, H2O2 decomposed to form H2O and O2. We have to calculate enthalpy of reaction. Here enthalpy of formation of H2O2 is given. Enthalpy of formation of H2O2 is actually value is minus 188 kilojoules per mole, and enthalpy of formation of H2O, water, is given, and it is minus 286 kilojoules per mole. Okay, kilojoules per mole. 286 minus 286 kilojoules per mole. Okay, now enthalpy of hydrogen peroxide and water. What is enthalpy of formation? 1 mole of a compound is formed from its constituent element. So enthalpy of formation of 1 mole of hydrogen peroxide is this much, and enthalpy of formation of 1 mole. Formation means enthalpy change when 1 mole of a compound. So enthalpy of formation of 1 mole of water is given. So enthalpy of formation of 1 mole of hydrogen peroxide is 188, but here 2 moles are formed, so it is 2 into minus 188. Now enthalpy of formation of water. Formation means 1 mole compound is formed. So it is minus 286. Here there are 2 water molecules, so 2. Now oxygen is an element, it is not a compound. What is enthalpy of formation? It is the enthalpy change when 1 mole of a compound. This is a compound. Hydrogen, oxygen consists of 2 different elements. This one is a compound, consists of 2 different elements. But oxygen is not a compound, it's an element. So value is 0. Now we have to calculate enthalpy of reaction. What is enthalpy of reaction? Enthalpy of products minus enthalpy of reactant. Enthalpy of product. This is enthalpy of product 2 into minus 286 minus enthalpy of reactant 2 into 188. So 2 into minus 286 plus minus minus it will become plus 2 into 188. Now after doing this one you will get an answer. Meaning value will be, if you multiply this with 2 minus 286 into 2 you will get minus 576 minus 572 plus 188 into 2 you will get 376. If you subtract this minus 572 plus 376 you will get a value, it is equal to minus 196 minus 196 kilojoules. So this is the enthalpy of reaction. Here we have to calculate enthalpy of reaction of this reaction. Enthalpy of formation of hydrogen peroxide is given. 2 moles are formed, so 2 into 1 minus 188. Enthalpy of formation of water is given. So 2 into minus 286 plus 0. So enthalpy of reaction is equal to enthalpy of product minus enthalpy of reaction. So 2 into minus 286 minus 2 into minus 188. We will get minus 196. Answer option minus 196. Answer option 1. I think it's clear. Question number 47. When 1 mole of a gas is heated at constant volume, temperature is raised from 298 Kelvin to 308 Kelvin. Heat supplied to the gas is 500 kilojoules. Then which statement is correct? So here number of moles N is equal to 1. When 1 mole of an gas is heated at constant volume, so isocoric process, so delta V will be equal to 0. Change in volume will be 0. Constant volume means isocoric process, delta V will be equal to 0. Temperature raised from delta T. Temperature is from let T1 be 298 Kelvin and temperature is from T1 to T2 which is equal to 308 Kelvin. So for 1 mole of a gas, when it is heated at constant volume, delta V is equal to 0. Temperature rise from 298 Kelvin to 308 Kelvin. Heat supplied to the gas is 500 joules. So Q is equal to 500 joules. Now then which statement is correct? Q, delta U, W, etc. So here we know the equation to calculate work. What is equations to calculate work is W is equal to minus P external into delta V, right? Here delta V is equal to 0, so W is equal to minus P external into 0, so W is equal to 0. Now according to first law of thermodynamics, delta U is equal to Q plus W, so delta U is equal to Q plus 0, W is equal to 0, so delta U is equal to Q. Now value of Q is 500, so it's 500 joules. So here we can write delta U 500 joules, Q 500 joules, W 0. Delta U 500 joules according to first law, since work is equal to 0, delta U will be equal to Q. So delta U is equal to Q is equal to 500 joules. So answer option 2, Q is equal to delta U. Q and delta U are equal. Q is equal to delta U 500 joules and W is equal to 0. I think it's clear. So next question number 48. Enthalpy of CH4 plus half O2 giving CH3OH, CH4 plus half O2 giving CH4OH is negative. So enthalpy of this reaction is negative. Enthalpy of this reaction, CH4 plus half O2 giving CH3OH is negative. If the enthalpy of combustion of CH4 and CH3OH are X and Y respectively, then the correct relation is here enthalpy of combustion of CH4X and enthalpy of combustion of CH3OH as Y. Now we have to calculate their relation. Now please listen carefully. Always enthalpy of combustion is negative. Combustion reactions are always exothermic. So here instead of X we can write minus X, because when you burn methane, energy will be released. So instead of X, let it be minus X, because combustion reactions are exothermic. Now if you burn CH3OH, if you burn any substance, those reactions are combustion reactions. Combustion reactions are always exothermic. They will liberate energy. So let this be minus Y. Okay. Now already we have discussed this. If enthalpy of combustion is given and they have asked to calculate any other enthalpies, if enthalpy of combustion values are given and they have asked to calculate some other enthalpies, then take the enthalpy of combustion of product to reactant side. We have discussed this in previous questions. So if enthalpy of combustion values are given, to calculate some other enthalpies, take the enthalpy of combustion of product to reactant side. So you will get minus X minus Y is equal to delta H, enthalpy of reaction. Now enthalpy of reaction is minus X. I am taking Y to this side, it will become plus Y. Sorry. Minus X plus Y is equal to enthalpy of reaction. So minus X plus Y is equal to enthalpy of reaction is negative. So from this we can conclude that X is greater than Y, because minus X plus Y is negative. That means X should be greater than Y. For example, if X is 5 and Y is 2, minus 5 plus 2, you will get minus 3, right? So if X value is greater than Y, you will get a negative value. I think it's clear. I will explain once more. Methane react with oxygen to form CH3OH and the enthalpy value is negative. Now enthalpy of methane is given X. Enthalpy of combustion of methane. Enthalpy of combustion of methane is X. But we know that combustion reactions are always exothermic. So let it be minus X. Now enthalpy of combustion of methanol is given Y. Combustion reactions are always exothermic. Let it be minus Y. Right? Now if combustion values are given and they have asked to calculate some other enthalpies, take the enthalpy of combustion of product to reactant side. You will get minus X plus Y. That is the enthalpy of reaction. So minus X plus Y is negative. So X should be greater than Y. So answer option 1. X should be greater than Y. I think it's clear. Answer is option 1. X should be greater than Y. I think it's clear. Option 1. The next question. Unit of entropy is. We know the unit of entropy. What is the unit of entropy? Unit of entropy is joules Kelvin inverse mole inverse. Unit of entropy is joules Kelvin inverse mole inverse. Unit of entropy is joules Kelvin inverse mole inverse. Now unit of enthalpy is joules or kilojoules. Unit of internal energy, joules or kilojoules. Unit of Gibbs free energy, joules or kilojoules. And unit of entropy is joules Kelvin inverse mole inverse. I think it's clear. Answer option 1. Joules Kelvin inverse mole inverse. Moving on to next question. Question number 50. Question number 50. In a closed insulated container, a liquid is stirred with a pedal to increase the temperature. Which of the following is true? So we are considering a closed vessel, and this vessel is insulated vessel. Insulated vessel means no heat enters or leave the system. No heat enters or leave the system, right? So Q is equal to 0. Insulated system means no heat enters or leave the system. So Q will be equal to 0. Now, according to first law of thermodynamics, delta U is equal to Q plus W. So delta U is equal to Q is equal to 0, that is delta U is equal to W. Now here W is not equal to 0 because we are steering with a pedal. A liquid is steered with a pedal. That means we are supplying work energy. We are supplying work energy. So work is there, work is not equal to 0, and delta U is equal to W, which is not equal to 0. So you can write delta U is equal to W, not equal to 0, and Q is equal to 0. Answer is option 1. Delta E and delta U both are same. So delta E is equal to W, not equal to 0, Q is equal to 0. I think it's clear. Here we are taking an insulated system. Insulated system means no heat enters or leave the system. Q is equal to 0. Now we are steering with a pedal. So we are supplying work energy. We are steering with a pedal. So we are supplying work energy. According to first law, delta U is equal to Q plus W, and delta U is equal to W. Here W is not equal to 0 because we are supplying work energy. W not equal to 0. So delta U is equal to W, not equal to 0. Q is equal to 0. Answer option 1. I think it's clear.